Welcome back to the Foundation in C# course. We are currently in Module 6, and this lesson we're going to be covering another mini project. So we're doing quite a few of these mini projects in this module because of the fact that we're learning some big stuff. And it's always good after you learn a couple of big things especially, or things that might be a little bit confusing or difficult to kind of visualize in a theoretical way. It's always good to put it into practice into a mini project. So let's switch over to Visual Studio and we'll get started with a new project. And it's going to be a console app for the .NET framework. And we'll call this project Card Game UI. And we'll call this the Card Game app. So the UI is going to be the console application. The solution is going to be the overall app. So Card Game UI and Card Game app. We could also call this Card Game if you wanted to. That might work because then it's going to create a cardgame.exe file. So let's just do that. Card Game and then Card Game app. We'll hit create. And we'll add our console read line at the end. Now, this is a card game app, but we're going to be really trying to do a minimal card game app. We're not going to try and do a full application because this will actually do multiple different types of card games. But really, we're going to do 2 card games, and we're going to try and vary them up a little bit to kind of show off the things that we've learned so far, which especially are access modifiers, abstract classes, and method overriding. So those are the things we're going to concentrate on practicing. And this is how you do mini projects. You actually build the project based upon the things you want to practice, not figure out what you need to do based upon the project. That's the opposite of real world in a lot of ways, because the real world, we start with what we want to accomplish and then we figure out how to accomplish it. But with this, the goal is practice, not the end application. Okay, so let's create a class, public abstract class. We're going to call this class the card app or card game. We use card game though for our namespace. So we're going to say, let's call it deck. Okay, this is a deck of cards. So it's going to actually, I thought about calling it cards maybe, but I don't think cards is right because it's plural and it's going to be a singular object. So this way, deck communicates that it's a card deck. We could even call it card deck if you wanted to, but I think cardgame.deck makes sense. Now in here, this is going to be our abstract class, which is the base class you have to inherit from. And we're going to create a few things that every card game needs to do or needs to have. Now we're also going to need another class first that is public class playing card, because a playing card has a couple of pieces of information tied together with it. So therefore we have to create a class for it. We should create a class for it in order to encapsulate all of what it is. Now we're assuming we're going to use a standard poker deck. Okay, so we're going to have 4 suites and ace through 10 plus jack, queen, and king. That's going to be our deck we're playing with for each of the suites. So a standard deck of cards. We're not going to have, Uno cards or, some other type of cards. This whole application is just about playing cards. So a playing card has a suite and it has a value. But both of these, I call them integers, but they're not integers. Well, what is a suite? Well, there isn't really a good way of representing that until we create a enum. Public enum card suite. And we'll say, and I just realized I said sweet, and I meant suit. Somebody yell at me. So we have 4 suits. We have hearts. We have clubs. We have diamonds. And we have spades. Okay, those are 4 suits in playing cards. All right. So now we can use this enum for the suit. We can also create another enum, and this will be the card value. And this is going to be pretty simple. We can actually say ace, 2, 3, 4, 5, 6. All right, so there's our card values. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. So now we have our card value. So now we have a class that represents a playing card. It has a suit and it has a value. So it could be the 2 of hearts. It could be the ace of spades. Now that setup work is done, we can concentrate on the methods we want to do in our abstract class. And those methods are public void create deck. And what create deck will do is it will actually populate a full. Now this one I think might end up being virtual at least, because there might be a case where a certain game needs it to be shuffled differently. So for example, maybe you shuffle it, you pull out 4 cards and show them to everybody and then shuffle the rest. Or who knows, there might be other options. But that might be one where we want to have an override for that. So we might make that one virtual at least. And then we're going to have a deal. So public, and this is where we return back a playing card and say deal card. Now that one right now, first of all, it doesn't return anything. That's why it's yelling at me. But that one right now returns just 1, and that doesn't seem right. It seems like we should return your whole hand to you when we deal. So therefore, probably what we're going to do is we're going to say, hey, let's go ahead and give you all of your cards. So therefore, a list of cards is going to come back. But deal how many cards do you get? Well, if you're playing blackjack, you get 2 cards. If you're playing poker, you get 5 cards. And other card games have different variations. So knowing which one to return, how many cards return, could be different for every game. So we have a couple of options here. One option is to just say int number of cards. And then you pass in, I want 5 cards, and it gives you back 5 cards. That could work, but the downside of that is when you're playing, let's just take poker for instance. You have 4 players at the table, and you're passing out cards. You don't pass out 5 cards, and then go to the next person and pass out 5 cards, and go to the next person. You pass 1 to every person, and then the second one to every person. So that wouldn't work with this method unless you pass in 1 all the time and said that's your deal, which doesn't make sense either. So I think what we need to do instead is we need to have this be abstract. Like so. So now we don't know how to deal the cards. We just know that you're going to have a method called deal cards because that's what happens in every card game. Therefore, we're going to make it abstract. And let's add one more method here. Public, we're going to make this virtual playing card. And this is going to be request card. So in certain card games, well, almost all card games, you have to request a card at some point. So let's just take blackjack because it's very simple. You have 2 cards in front of you and it doesn't add up to 21 or even close to 21. Let's say you have a 2 and a 3. That's 5. And it's nowhere near 21. So you say, hit me. And it's going to request 1 more card from the dealer. The dealer gives you that 1 card and then you have the option of continuing or not. In poker, we have the idea of I want to give back 2 cards and get 2 from you. So there's that option as well. So what we're going to do is we're going to create a standard request card. Just 1 card, because you can call it multiple times. But I think that for poker, we'll have to override this and call the base request card, but then also call the return card for returning cards to the discard pile. So with that, I think we have the basic methods I want to work with. Now, we're not going to actually play the games. We're not going to create a full-on game for this, but I think this is a good start. Now we have a structure in place. Let's actually start creating these different things. So first, I think what we need is we need a private list of type playing card that's going to be the full deck. What this will be is when we create the deck, we're going to populate this full deck here. Now from this, we'll have full deck in our create deck method. Now, this is a little tricky, and this is where these mini projects really start helping you understand how to work with your code, what you learned. Because you watch a example, you go, oh yeah, I got it. But then you actually start doing it and you run into these problems. And the problem I run into is, okay, down here I have playing cards. We're a card suit and a card value. These are enums. How do I create a deck of enums? I can do this for int. Instead of I could say something like suit is 0 and suit is less than 4. And then I can do a for loop again, and I can say val, and val is less than 13. So I have, well, it's actually an enum value. And if you notice before when I had my enum values, let's pull the other one up. So I say card value dot. If I mouse over, let's say 8, it says 8 has a value of 7 and 4 has a value of 3. So they're actually integers behind the scenes. So I can apply these, I can put these integers in as long as I cast it to the enum type. But if I pass in a 5 or even a 4 to suit, there is no 4. It will crash. But since I know I'm limiting this to less than 4, because it's 0, 1, 2, and 3, because it's 0 based, then I know that this will work every time. If I'm going to ask the user for a card and I ask for 2 numbers, I've got to be very careful to do my due diligence beforehand to check those numbers fall in the right range or ranges. Otherwise, we could have some problems. All right, so we're going to say card value, and we're going to pass in the val, which is that 0 to 13. So this will create a deck, but the deck is going to be in order. It's going to start with picking the first suit, which I believe the suit's down here, hearts. So hearts are the first suit. And that's going to say, okay, from 0 to 13, or 0 to 12, actually. So it's going to start with ace, ace of hearts, 1, 2 of hearts, 3 of hearts, 4 of hearts, all the way up through king of hearts. And then it's going to be exit this for loop, go to the top, hit the next suit, which is clubs, and do the same thing. So we're going to have this deck like it comes from the factory, which is fully in order. It's not shuffled in any way. So that's great, but we're definitely going to have this shuffle deck method. But it looks like now we have a full deck if we call this create deck method. Let's call one more thing before we go. Create deck, I don't think that we want this to append to the deck. So if I call create deck twice, I don't think I want to add a second deck to my existing deck. Therefore, what I'm going to do is at the very beginning, I will say full deck equals new list of playing. You know what? No, not full. I'm going to say dot clear. And what that'll do is we'll just clear the deck out, but keep the same memory space for that list. It's a little more efficient than create a new list. Also, if something had a reference to your deck, it wouldn't reset or disconnect those two references. So this is what we want, is a clear. All right, now we have the shuffle method, which for right now, it is virtual, but it'll probably be just normal shuffle. How do we shuffle this deck? Again, that's something that is going to kind of push our knowledge. In fact, we're going to have to add something new to our toolbox, and that is a random number. We'll also work with a lambda expression. So we're going to talk through both of these things. Now, if you're not sure how to do these things, no problem. What we're going to do is we're going to simulate the idea that we just don't know. And so we're going to Google it. And we Google it, and we come across a Stack Overflow post that says, here's how you shuffle a list. And it gives you in 2 lines, which is awesome. I'm going to type those 2 lines out, and then we're going to look at them. In fact, you know what? I'm going to copy and paste. I have the post pulled up here. Just going to copy and paste. And there is the solution. And it's the most upvoted solution, and it's the one that everyone says, oh yeah, it works and it's simple. And it is simple, it's 2 lines. But it's 2 lines we've not used before. So let's talk it through. First one is this random. What is this? Well, built into Visual Studio is the idea that we have the ability to create random numbers. So we can say, I prefer RND, but our rand is fine too, equals new random. And what this will do is we'll create a system we can use to generate random numbers. Now be very careful with this here, because when I say random, I really mean pseudo-random. It's not entirely random. If you're going to write a cryptographic library, you wouldn't use this random. It's not random enough. What it does is it creates a random number based upon the current tick value of your clock. So it's only going to happen once, and it's something that's going to change all the time. With that being said, if you knew exactly which tick the clock was on, you would know what the random number was going to be. And then from that, you'd know what the next random number is going to be. However, if you don't know that, and most people wouldn't, then it's random enough. You can also seed it if you want, meaning you give it a starting value to base itself off instead of a tick value. But even that is somewhat difficult, because then if someone found out what that seed value was or how it was calculated, then it would be a problem. Now, the other thing with random numbers is we never do this equals new random over again. We want to keep this random number basically once for the entire application, because now it can make a new random number based upon the old random number already being created. So it doesn't use the old random number that I'm aware of, but what it does is it says, okay, we're going to create a new one, and it doesn't have to reseed itself. If you were to create 2 of these variables at once, they'd actually have, or could have, the same random number. Not ideal, because that's not random. So with that being said, the key things here are create this once, and then notice we say rand.next or rnd.next for us. That's going to create the next random number, and that's a good thing. That creates a truly more random number, okay? So it says var random list equals their list dot order by. So we're going to do the same thing. We're going to take our full deck, but we're going to put the values into the draw pile. So draw pile equals, and our full deck dot order by, And this is a lambda expression where I say x equals greater than. And I could say rnd dot next, like so, to list. So there's our whole shuffling mechanism. It's just 2 lines. And it's based upon what we got from Stack Overflow. But if you don't understand what's going on, you really shouldn't just copy and paste it into your code. Because otherwise you might be introducing bugs in your program that you can't then fix, or you might have code doing something unexpected. So always understand why you're doing something. So let's talk it through. The order by allows us to order our list. It sorts the list in a way that based upon a value. So you pass in what value. So I could have said here, x dot suit. And what that would do is it order the items based upon their suit. But instead, I said rnd dot next. So I'm ordering it based upon a random number. Well, what's that doing? Well, it's essentially, behind the scenes, assigning each item in turn to a different random number. So it pulls the first one up and says, okay, here's your random number. And then the next one it says, here's your random number. Now, is that before or after the previous one's random number? And it says, okay, it's before. So therefore, you put the second one before the first one. And of course, since it's random numbers, they're put all over the place. And that's exactly what we want. We want to shuffle the deck. The result of this, if you mouse over order by, is an I-ordered enumerable, which is an overloaded class, inherited class that inherits from, I believe, I-enumerable and adds some extra features. But we don't want an I-ordered enumerable. We want a list. Fortunately, the I-ordered enumerable has a method attached to it called toList, which converts an I-enumerable to a list. And since I-ordered enumerable is an I-enumerable, we can use the toList method. Confused yet? Hopefully not. So this order by, what's this doing? Well, the lambda expression is essentially a shortcut. So if I were to create a method, let's create a method here called public. We're going to return a playing card, and we're going to give it a name. Let's call it get order. We're going to pass in a playing card. We're going to give it a name for that. So let's do card. And then curly braces, and then inside here, I am going to return a value, which is where it's going to go. Okay. Now I'm simplifying things, and actually, there we go. Int. I'm going to say if the if card dot suit equals clubs, let's say, return 1, else return 0. Something like that. We're creating this kind of method that does a little bit of work, and we can even shrink it down a little bit and return one value. Well, a lambda expression says, I'm looking at this and thinking we don't need that much stuff. Because, yeah, we know it's public. We don't really care. In fact, we're going to scope it to just this little bit, because this is a method here. That's a full method. So it's saying, yeah, we don't need all that. Instead, let's cut out the public. And we know the return type is we can assume that based upon whatever order by says we need. In fact, it says playing card and int. So therefore, we don't need the return type. And do we really need a method name? Nah, we can make it anonymous. And we know that based upon what we're passing in, that it's a playing card. Don't need that. And you can call it anything you want. So why don't you call it something simple like, I don't know, X. We don't need parens because we know that that's what we're going to do. So now we've boiled this whole thing down to X. And these curly braces here, that's a little much, right? We don't need curly braces. Let's instead define the whole thing as equals greater than, also known as the arrow function. That's just saying, hey, we're going to call the following code every time. And we can boil this down by taking this off and this off. And since in our case, we're just finding the value of random.next, instead of doing all this, we can just say rnd.next semicolon. But you know what? We don't need semicolons. It's only one line. Therefore, get rid of semicolon. Therefore, what we have left is that. That's an entire method. And what we did, we went through and took out everything we didn't need. We can assume. And so it says, I can assume this, I can assume that, I can assume this, I can assume that. And it starts taking things away until it boils it down to that one little line. And they pass that thing in to our order by. An order by takes a method. It's actually called a func because it takes in a playing card and it returns an int. We'll cover this more in the future, but for now, we need to use one. Therefore, we're going to learn a little bit about them. So it takes in one value and returns a different value. And that's what order by is expecting. And since we told it what it takes in, playing card, and what it returns, int, we don't need to specify those things. And so all we're specifying is, hey, give it a variable name so you can use it, that thing you're passing in. And in fact, I didn't even need it. So I didn't even use it here, but I could have used it. I could have said x dot something, but that was it. That boils the entire method down to that. So that's what a lambda expression is, and how it can be really, really powerful. Because it's creating an entire method that's called on each item in our full deck. But it's so small, it's not like we're writing a ton of code to just say, hey, give us this number next. Now, if you have multiple lines, you could put curly braces here and actually put your full code in. But for most lambda expressions, it's just a little bit of code. So that's the order by. So it's going to order it by this number, which is random. Therefore, it's going to be randomly ordered. And at the end, we have toList to put into the right type. And that's going to populate our draw pile. So that's what those two lines do. And that's why they're really powerful for our shuffled deck method, because that's all we need to do. We now have a shuffled draw pile. Now, let's have the request card do the very, very simple thing, which is going to be, it's going to request one card from the list. Where it requests it is up to us. So let's get this request card working. The first step is to pull something from our draw pile. So let's do a playing card. Let's say output equals our draw pile dot. We have this method called take. And what take does is we can return a specified number of them. We also have the idea of just grabbing one. So we could return just one if you wanted to, where we can, there's a lot of different possibilities here. We can grab the last one. We can, get the first one, which I think right here, what we want to do instead is we probably want to use the take. I think the take is the one that is kind of the simplest to understand. Now, the problem with take is that if we want to take just one, it returns an IEnumerable of playing card. So we can't just put that in a playing card, but what we can do is say first. And that will take the first item. And since there's only one, that's the one it's going to put in a playing card. Now we have our playing card. But the key thing here to understand is take does not remove. It's not take and remove, it's just take. Therefore, we have to say drawPile.remove and pass in our output item. And it says, okay, I can find that one, and it removes that one from our draw pile. And finally, we can return output. So that's our request card method. It's going to take one from the draw pile, it's going to remove it from the draw pile, and it's going to return it to the user. So that's really all we need for our deck, that's a lot. But let's now shrink these down and create a couple of child classes. So public class poker deck, which inherits from deck. And it's going to yell at us because it says, hey, you have not implemented everything yet. I'm going to implement the deal card. Okay, so this is going to deal cards to our users. So it's going to be what they use to pull a card, or to pull a card from all, we should say cards. So we deal cards. That's going to return a whole hand. Now, how they do that with poker deck, it's up to us. We're going to be simplistic about this and actually pass out 5 cards to one person, 5 cards to the next person. So that's what we'll do, but we don't have to. Now, the way I'm going to do this is I'm going to say a list of playing card called output equals new list of playing card. And then I'm going to do a for loop and say where I is less than 5. We're going to do 5 cards because poker is 5 cards. And therefore, we're going to say output.add, and then we can call the request card method. And what that will do is it'll request one card, we'll put it into our output list, we'll do that 5 times, and then at the very end, we can return output, otherwise known as the player's hand. So that's how we work with the poker deck. Now, request cards would work just fine. We don't have to override that. And we did override the deal cards. We don't need to worry about shuffling the deck or creating the deck, which we can't modify anyway. But what we can do is we can say, well, when you first come in, so let's create a constructor. When you first come in, I want you to create the deck. I want you to shuffle a deck. That's what I want you to do when you first come into this application. I think that makes sense. So that's our poker deck. Not really too complicated, but pretty clear. So now when we come up here to our static void main, we can say poker deck. Let's call it deck is fine. Equals new poker deck. And if we say deck dot, we have a few methods. We have shuffle deck, we have request card, we have deal cards, we have create deck. I'm not sure I want the create deck method being available, because that seems like something that isn't something we should expose. So let's figure out a different way of doing that. All right. So first, because of the fact that I want to deal with different types here, from protected to internal and all the rest, I want to actually move these off into their own file locations at least, and maybe even a class library. In this example, I'm just going to move them over to. I'm going to keep it in the same assembly. Therefore, I don't have the option of really using internal here because it's in the same assembly. In the real world, I would put this in its own class library, and then I'd have that option back of saying internal. However, I don't, and that's okay. I'm going to make this protected. Now, shuffle. Now, one more thing, and that is that the request card doesn't really make sense for poker, because yes, we want to request a card, but we really want to return cards too. Therefore, what I'm going to do is, even though we have a method for getting one card, we have that method here, request card. We're going to create a new method and say, instead of request card, it's going to be request cards, or I think request cards is fine. Public list of playing card, request cards. And you're going to pass in a list of playing cards to discard. And then what we'll do is we're going to create a list of playing card called output. And then for each card in cards to discard, so for each one of these, what we'll do is we will call the request card. So output.add request card. And we're going to add a new twist to this, where we'll say the list, which is the discard pile, discard pile.add. We're going to pass in that card they're discarding. So every time they pass in one or more cards and call the request cards method, it will say, okay, you have 2 cards you passed in. I'm going to add 1 card to the list and take 1 card out of your discard and put it in the discard. I'm going to go to the next one. I'm going to add 1 card to your list, and I'm going to discard the one you passed in. And we're all done. We're going to return output. So now, if they pass 2 cards in, it's going to put both of them on the discard pile and give you 2 more cards. So that's the request cards method. So we have the idea of this request card, which may or may not be something we want. It may be that we say, you know what? I don't want you to directly request cards. So what we can do is we can make this private. Oh, not private, protected. where we only have access to it in the poker deck and in the future blackjack deck, but not to the user themselves. Instead, they call the request cards method for poker deck, and they have to pass something in. And we'll do something different for the blackjack deck, because they just request a card. And that may mean we should rename this, since the blackjack will want to have the request card name. But we should give it something a little bit different, like draw one card. How about that? And we'll do Control Dot here to rename it everywhere. So you have the draw one card. And that's available internally for poker and again for blackjack or whoever else. But now up here, when I say deck dot, I don't have a draw one card. I have deal cards, which is the first one right here. I have request cards. That's where I pass in cards and get back cards. That's a poker thing. And I have shuffle deck. That's kind of the way it works with poker. That's pretty much your options. So with that being said, we've kind of wrapped up the poker deck. Now let's do it again, but this time we're going to do it for the blackjack deck. Public class blackjack deck, which inherits from deck. And again, we have to implement that one method. Since it is, and notice it puts the override and everything. It's just really nice when we just do the Control Dot and say implement. So it has all the structure I need. I just need to change what this does. Now, for the sake of time, I am going to grab what we do here. I'm going to copy it. I'm going to come down to my blackjack deck and I'm going to paste it in and change it to 2. Because in blackjack, you get 2 cards. Now, let's also, we don't need to have all these things still in here. So let's move a lot of them over. That way, we kind of clean out this file. Now, I created a file for my enums. I don't always do that. It really depends on how I'm doing things. I might just create one file called enums and then put all my enums in there. But in this case, I think this works just fine. I would probably create a folder though. So let's add a folder and call it enums. And then move my enums into it so that you know here's my available enums. And there's a model, which I can create a models folder. And I probably should call that playing card model instead of playing card, but that's okay. I can come in here to playing card and call it playing card model. Control Dot, rename it everywhere. Notice how many places it's going to rename it. And I do a Control Dot again. And it says rename file to playing card model.cs. Notice it still says playing card.cs. Yep, do that. So now a file matches my class and we're all good. Everything works just the way it should. Playing card model everywhere now instead of playing card. Okay, so now we have our deck, we have our poker deck, and down here we have our blackjack deck. Well, let's create our constructor, which is going to do the create deck and the shuffle deck, just like our constructor did for the poker deck. And I probably could have put that in the base class, but I think this works here too. It's kind of up to you. You might have more logic to put into your shuffling, especially if you do want to pull some cards out first or whatever. But in general, I think that works. And now we have our deal cards already done. We have request cards. Well, we need one of those. Public playing card model. Request card. It's a little different because in blackjack, we don't say how many I want. We just say I want a card. And so with this, it's going to be the draw one card and return it. So return, draw one card. That's it. We're essentially calling this internal method, but wrapping it in a public method so we can actually call it externally. So now we have the draw or request card, which draws one. Let's look at anything else in here that we might want to change how it works. We have the draw, we have the deal, the shuffle, and the create. I think those should be the same. I don't think there's anything else that we should think through with this. So I think at this point, our blackjack deck is now done. It does things a little bit differently, how it deals the cards, how it requests the cards. But otherwise, it's pretty close to deck. And the same thing with poker. Does things a little bit differently, but in the end, it's still using a deck of cards. So that's a more full example of how we might create a mini project for what we've learned about abstract classes and the access modifiers and method overriding. All right. So we've done some overriding. We've done some abstract class stuff. We've done some looking at the different modifiers and using the one that works best for us. We didn't actually call this. We could do that. Why not? Let's just call a poker deck because it's got 5 cards in it. And so we're going to run this, and I have 4 hearts and a spade. So I have a 2 of hearts, a 4 of hearts, a 3 of hearts, an ace of hearts, and a 7 of spades. We should actually flip those around. Let's run it again. And this is one of those things that you have to be careful of with random numbers, is make sure that it truly is random and that your shuffle is working correctly. So I'm going to run it again, also flipping that around, just to make sure I don't get 4 hearts again. And I did not. I got a 7 of diamonds, a 5 of diamonds, a 2 of spades, a jack of diamonds, and a 5 of spades. So not an ideal hand, I wouldn't say, but we've got something that we can start working with. So it seems like our system is working. Let's tweak it a little bit more to say of, and run it one last time. And now we have the jack, the ace, the 9, the 2, and the 6. And I have clubs, hearts, hearts, clubs, and clubs. Cool. Now what we need to do is we can change this from poker deck to blackjack deck. Everything else stays the same. If I run this, I've got a 7 of spades and a 4 of hearts. That gives me a grand total of 11. Good time to hit me. Okay, so that's the application. That's all there is to it. I say all there is to it. That's quite a bit. But what it did is it gave us a good chance to go over all these different pieces and see how they fit together and see where we might need to learn something new, like the random number or the lambda expression, or where we might just need to think about how we do things. How do we convert an enum to an integer or an integer to an enum? Those are kind of real world things that come up when you actually build an application. That's why I stress over and over and over again, build these applications. Don't just watch what I do, because as soon as you just relax and watch what I do and just say, yeah, I got it, then you miss out on and you start falling behind because you haven't actually gotten your feet wet in what you're learning. And you haven't encountered all these kind of edge things that only come up through actual practice. So definitely practice, practice, practice. So let's look at our tip for today, which is there's more than one way to accomplish something. Pick the way that's easiest to maintain and improve. If you don't know what that is, pick the way that you can get to work and then try and make it better. And that's a really important thing that people often kind of get confused by or stuck on. And they say, well, I heard someone say do it this way, but you're saying do it that way. And I thought maybe I could do it this way. You know what? Get it to work. That's chore number one. If you can get it to work, excellent. Now, there may be better ways of doing it, and definitely try and make a better way or try and find a better way. But job number one is to get it working. But after that, if you have multiple options, pick the way that's easy to maintain. You will thank yourself in the future. Because if it's easy to maintain, it's also easy to improve. If those two things are true, then your application can grow and scale over time. So that's just my advice for you is pick the way that's easiest to maintain, easiest to improve. Okay? Your homework is to build a similar project to what we did here. So I built this project and we did a poker app and or poker class and a blackjack class. Maybe pick two different types of card games. Maybe figure out, well, how would we do two decks? Or what if we had some other methods that might do other things? Or maybe try and build out the rest of the application where you can actually play it. Add a couple of players and see what happens. Just try to expand your knowledge a little bit and try different things. Once you've done that, and once you're kind of comfortable with where you're at and comfortable with doing what we've done in this video, go ahead and move on to the next one.